What's up? What's up? It's your man Jimmy Chan. So today we're talking about binomial probability distribution. So this is a discrete probability distribution, meaning that we can count the number of trials that there are, or the number of experiments that there are. So the only two outcomes are success and failure, and they're not related to each other. They're mutually exclusive. Okay. The trials do have to be independent. And in terms of X, denotes the number of successes. So I can't have more successes than the number of trials I have. So if I was to try it twice, I can't have 3 successes. It doesn't make sense. I only tried it twice. Doesn't mean there's no way possible of getting more than that number of successes. Okay. Which would be cool if it was possible, right? I can play the lottery ticket once and win 3 times. I would love that for that to happen, but it doesn't occur that way, right? All right, so in terms of notation wise, N is the total number of trials or the sample size. P is the probability of success, always in decimal, so don't forget that, please. X is the number of successes that can't exceed the number of trials. And the probability of failure, so since the probability of success is P, then and the total probability is going to be 1 or 100%, then the probability of failure will be 1 minus that probability. So let's try a word problem here. So according to CTIA, 72% of adult Americans would rather give up chocolate than their cell phone. Okay, so what is the 72%? Well, 72% is going to be the probability of success. So that is going to be my P. All right. In a simple random sample of 300 households, okay, what is that? 300 households is going to be really my number of trials or my sample size. And it says determine the mean and standard deviation of number of who rather give up chocolate than their cell phone. Well, I got the probability of success here. Well, what's the probability of failure? Well, probability of failure is going to equal to 1 minus the probability of success. So that is going to be 0.28. All right, so that is my probability of failure. Why do I need that? Because I need that in my standard deviation. So the formula for mean is N times P. So the number of trials times the probability of success. So my mean is going to equal to 300 times 0.72. So my mean is going to equal to 216 households. There we go. All right, and the standard deviation is going to be the square root of the number of trials times the probability of success times the probability of failure. So let's duplicate that, bring that up here. So I gotta have the number of trials times the probability of success times the probability of failure. And that, ladies and gentlemen, is going to come out to be 7.8 households. There we go. Now, you're going to get questions about if the data are usual or unusual. The only time that it's going to be unusual is if it's going to be above this upper bound or below this lower bound. So we actually have to find the upper bound and lower bound so that we know if the data or the results are unusual. So this is just going to be 2 standard deviations away from the mean. One is taking the mean, which is 216, plus 2 times 7.8, which is my standard deviation. And the other is doing the same thing, except it's going to be subtraction. So my upper bound in this case is going to be 231.6, and my lower bound is going to be 200.4. So if I have any data points that are above 231.6 or below 200.4, those would be unusual. Okay? All right, so let's actually find probabilities here. So when we're looking for probabilities, you can do this on the TI-84, which I'm giving you directions up here, while the directions for the decimals are all the way to the bottom. So here we go. So to find these probabilities, you would do second vars, which is distrib, which stands for distributions. You can see it there as well. In my case, A was binomial PDF and B is a binomial CDF. What's the difference between PDF and CDF? Well, PDF is talking about a single success. Okay, so let's say I play the lottery 20 times. What is the probability? And I want to know what are the chances of me winning 5 times. That's it. I don't care about 6 times. I don't care about 7. I don't care about 4. I only want to know what's my chances of winning 5 times, and just 5 times, right? Where the CDF is an interval, okay? Meaning the CDF would be like, okay, what's the chances of me winning 0 times, winning 1 time, winning 2 times, winning 3 times, and winning 4 times, and winning 5 times. So not just 5 itself, but 5 and 4 and 3 and 2 and 1 and 0, right? So the interval is always from 0, all right? So let's do a couple of problems here just to show the difference between when we would use a PDF versus a CDF, all right? All right, so here we go. So in this case here, we have number of trials. So no matter what we do, what we're entering is always number of trials, the probability of success, and the number of successes. So you do have to remember what N stands for, what P stands for, what X stands for, right? N is the number of trials, P is the probability of success, X is the number of successes, okay? So in this case here, in the first case, number of trials, probability of success, and I want only 20, so exactly 20. So in that case, I do have to do a binomial, in this case, a PDF, because I want exactly 20. So this will calculate, and don't forget that this is 0.32 for the probability of success, and I want exactly 20. So this is only going to calculate the probability of getting only 20 successes, not 21, not 19, just 20. So when you plug that in, you're going to get a 0.0564. Okay, so that's your probability of getting 20 successes. Okay, this next one, you're gonna see this example twice, one as a PDF and one as a CDF. So let me go ahead and show you what the PDF side is gonna look like. Now, the PDF side, if you look at this, this has less than or equal to, which means that it includes 6 and it includes 8. So what we want here is 6 successes, 7 successes, and 8 successes, okay? There you go. So in this case, I want to do the binomial PDF of this, 12, comma 0.7, comma for my 6. And then I want to do it again for my 7 and for my 8. So for my 7 and for my 8. And since PDF only does individual ones, that's why I got to do the 6, I got to do the 7, I got to do the 8 because they're individual. And then I can add these together. And that is going to give me a 0.4689. All right. Now let's look at CDFs. All right. CDF is always going to give you number of successes from 0 all the way to whatever you decide the number of successes are. All right. So in this case, when I look at this, that's x is less than or equal to 10. That means I want 0 number of successes, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, because remember, this includes the 10. So I want all the way from 0 to 10. So I would do a binomial CDF of 41, comma, 0.15, comma, just 10. Because I know I want to go from 10 all the way to 0. Okay? So again, CDF is always going from 0 to the number of successes that you want. So that's why I just put down 10, and it's assuming that I want from 0 all the way to 10. And that is going to come out to be, 0.9645. All right? On the next one. So what does this want? Well, this wants everything less than 20. So that means I want 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. I don't want the 20 because look at this. It says less than 20, so I don't want 20. And I can't have decimal successes, right? I can't have a half a success, right? If I was to try to ask a girl out, it's either going to be yes or no. She's not going to say, well, 0.2 yes and 0.8 no. Like, she's not going to do that to me. So I'm only going to have 19 successes here because it wants to be less than 20. So this is going to be a binomial CDF because I'm going from 0 to a number. 30, comma, 0.55, comma, 19. Right? Notice I didn't use the 20 because it's supposed to be less than 20. And that is going to give me 0.8650. The next one. What does this want? It wants greater than 10. Okay? Greater than or equal to 10. So this wants 10, 11, 12, ... all the way to 41. Actually, let me do it this way. Comma, 39, 40, and 41. Okay? But I don't have a CDF that can take care of that. Right? So the only thing I can do is I can find what 0 to 9 would be, right? I can find that and subtract it from 1. So in this case, I have to do 1 minus the binomial CDF of 41, comma, 0.15, comma, 9. Because again, the CDF is always from 0 to whatever. So if I know this percentage, 1 minus that percentage would be this percentage. All right. So in that case, this is going to come out to be 0.0774. Okie doke. All right. This right here wants greater than 20. So what does this want? This wants 21, 22, 23, all the way to 28, 29, and 30, right? Again, I don't have a CDF of that. I can get from 0 to 20. I guess I should do it that way instead. Let me erase this here and say it's from 0 to 9, right? So these tend to happen with the greater than signs. So I can find the binomial CDF of 0 to 20 and subtract it from 1, and that will give me the rest. All right. So again, 1 minus the binomial CDF of 30, comma 0.555, comma 20. So if I know this percentage, subtract it from 1 would give me that percentage. So that should give me 0.0694. All right, so now example 7 is going to give me, again, the same example as 2, but now we want to use CDF. So what does this give me? This gives me, oh boy, this is going to be a little fun. So again, this wants 6, 7, and 8. Okay? So with that being said, I can get from 0 to 5, right? The issue is that I still have 9, 10, 11, and 12 though, right? I still have those. But those doesn't really matter, right? I know that I want, actually, you know what? Let's go ahead and put that down. I still have 9 to 12, right? Because I can't have more successes than trials, right? So if that's the case, I can write that. That part's easy, right? That part right there is just going to be a binomial CDF, of 12, comma 0.7, comma 5, right? That's easy. I can do that part, no problem. However, this is not going all the way to 12. This is only to 8. So what I'll have to do is say, okay, what percentage do I have to find it to? I got to find it to 9 and then subtract this. Actually, no, I'm sorry. I got to find it from 8, right? All the way down to, so if you guys look at this, actually, let me, how do I want to do this? If I go from 0, 1, 2, 3, 4, 5, 6, 7, 8. All right. So if that's the case, then I'm going to find the binomial CDF of 12, 0.7, and 8 will give me everything in purple. All right. That will give me everything in purple. So really, this part won't matter anymore. Okay. That will give me everything in purple. And if I could just take out everything here, then what I will have left is just 6, 7, and 8. So that's exactly what I'm going to do. So I can actually erase this as well and actually bring this whole thing down a notch, right to here. Okay, so this right here should be everything in blue that I just highlighted. And I can just, again, I would just subtract these two, right? Because this is going to give me everything from 0 to 8. I'm going to subtract or take out everything that's in blue so that I will be left with 6, 7, and 8. So that would be my so-called equation that I would type in. And therefore, I'm going to have this probably as 0.4689. All right. So what about Desmos? Well, in Desmos, so if you're not using Desmos, you guys can end the video. But if you're using Desmos, here it is. So if you go into functions and scroll down to distributions and hit binomial dist. All right. So that is going to be asking for trials, comma, success probability. All right, so like example 1, my trials, so let me go back to example 1. Trials were 50, probability of success is 32%, so that's why I type in. And it wants exactly 20, so my minimum and maximum is going to be 20, and I'll get that percentage. Let's check. That's exactly what it is. How about the 6 through 8? Well, the 6 through 8, which is example 2 and 7, was 12 trials, 70% probability of success. I'm just going from 6 to 8. And it will take care of that, take care of the subtraction for me. And there it is, which is right here. Look at that. Nailed it. All right. And then this one here is example 6, which was greater than 20, right? So when we did greater than 20, we said it's 21 all the way to 30, okay? So when you type this in and check this off, this 30 is going to already be there as a maximum, and you'll have a 0 as a minimum. So you're just going to change the minimum to 21 because when we did example 6, we said we wanted from 21 all the way to 30. So 21 is my minimum, 30 is my maximum, and there we go. All right. So you don't have to worry about PDF or a CDF with the Desmos. All right. However, with the TI-84, you do have to worry about what if you're using a PDF or a CDF. Well, I hope this helps. If there's any questions, please let me know. See ya. Bye.